they get back, especially the day scholars. We do exercises for everyone. We are always online full-time for consultation in any subject. You just need to connect to us and say it is mathematics. When you say mathematics, we refer you to a teacher who will immediately respond to your challenges. We give tests and examinations. We do revisions. We do anything which is done at school level, we do it here at Yaka. So we found that it was good for us to have this seminar. And I want to thank everybody who made it a point to be here. I've already introduced myself. Daniel Alera is my name. And since we are not very many, I would request us to introduce ourselves. I'm going to be calling the name. You introduce yourself, tell us like the combination possibly that you're doing, and then we move on. I'm going to start with Masiga John. You tell us your name and then the school plus the combination. Thank you so much. John is connecting the audio. If you can hear us, please. Okay, fine. Okay. Who is ready to introduce himself or herself? Let me give chance to everyone. Our students, our parents who have joined us today. You can raise up your hand. You can raise up your hand. I'll pick you. If you're ready, you have your audio on. Yes, Aaron. Aaron, unmute.
My name is Aaron Asate Israel. I am in Hillside Primary School, Nalia, and I am in P4 Orange.
Oh, fine. Thank you so much, Aaron, for joining us. Thank you. Who else? Raise up the hand. I will be in position to pick you. I see a hand up here. Yes, Jean-Claude, unmute. Jean-Claude.
Yes, my name is Jean-Claude from and my school is in Nakivali Estate.
Okay, fine.
I had no physics, but I'm interested in this physics.
Okay, please. Fine. Thank you so much, Jean. I pray that your expectation is met here. Good, thank you. You can take down your hand. Hello, I wouldn't want to leave anybody behind. I wouldn't like to want to leave anyone behind. I see Prince Ino. I see Calclas Joseph. I wanted you to say hi to us and then we move on.
All right, Prince Ino is online. Are you getting me?
You are very loud and clear.
Yes, I'm called Innocent Paul. I'm a parent. I have a child who is in senior 4 sitting this year. I would like to be part of this program. I monitor how it moves, so that next time I also connect him online.
Fine, thank you so much. Thank you, our parents, for joining us online. Good, the rest, we shall get to know each other as time goes on. I'm going to share the questions which we are going to discuss now. Basically, the physics, the seminar is basically an A-level seminar, physics, and we have chosen specifically physics paper 2. As you know, the whole world, when you hear that people have passed physics, be sure that they have passed physics 2. When you hear that people have failed physics, be sure that they have failed physics 2, especially in A-level. Yes, it's also true in O-level, but the trend is too much when it comes to A-level. You hear people have failed physics, it is in A-level. That one you have to be sure that is physics 2. Now, if you hear that people have failed physics 2, be sure it is either section A or section C. Section A is basically light, and section C is basically magnetism. So that's why we were guided by some of these things in choosing this topic, we chose the topic called optical instruments. So we are discussing optical instruments. By the time you leave here, you'll get to know what optical instrument is, what an optical instrument is, what it is used for, and how do we solve related problems involving optical instruments. So in our discussion, we shall be asking questions here and there. We shall be sharing. Feel free to submit whatever you have, though we shall not do it in chorus. You raise up your hand. After raising up your hand, I will get to see you, and then I pick you to submit. Then too, when you have anything which probably I have not picked you can use the chat section. You type it there. I'll be in position to see, and then we get it done. In this discussion, everyone is free to pass out his or her opinion. Once you pass out what you know, we discuss it together. After discussing it together, we agree that, yeah, this is supposed to be this and that. So basically, it's going to be a discussion, but I'm very sure by the time we leave here, optical instrument will not be any problem again everywhere you will be going. Allow me to share the question in the chat section. I'm going to share the question in the chat section so that those who never got the chance to see it can So the question we are going to discuss already in the section, chat section, you can check through and download it so that at least when we're talking about some of these things, you are not left behind. But thank you. Let's get into the real matter. We are talking about optical instrument. That's what we are discussing, an optical instrument. Now, before we talk about its definition, I always want us to start with the examples. See, when you use an example and then you get to the definition, truly you can easily understand what it is. Back to us. Who can give us an example of anything we are calling to be an optical instrument before we start the discussion on those questions? An example of an optical instrument that anyone knows. You can raise up your hand or you can type in the chat section. I'll be positioned to read it. Yes, an example of an optical instrument that we know. Yes, please. I'm waiting. You can raise up the hand or you use the chat section. Okay, I don't see any hand up. Yes, Aaron, I've seen Aaron. Yes, Asante Aaron.
Microscope.
Microscope, good. Microscope is one of the examples of optical instruments. Microscope. That is very good. Microscope is an example of optical instruments. Yes, Prince Eno.
Telescope.
Very good. Telescope is also another example. Telescopes. Yes, could somebody be having another one? Yes, Sir Joseph.
A magnifying glass.
A magnifying glass. A magnifying glass is a form of a microscope. I'll talk about that ahead. When you talk about microscope, a magnifying glass is also a microscope. Good, thank you. Thank you. Can Prince Eno, do you want to add another one?
Hand lens.
Hand lens, hand lens. Good, hand lens is also a magnifying glass. Let me hear from Aaron again.
Periscope.
Periscope. Periscope, yes, periscope. Periscope, yes. Let me hear from Joseph. Do you have another to add?
Lenses.
Lenses. Lenses. Yeah, good. At least we already have the ideas about optical instruments. We already have the idea about the optical instruments, microscopes, telescopes. We have the next one under this is the camera. I expected somebody to talk about the camera. And then lastly, yes, I expect somebody to talk about the camera. And lastly is a projector. So basically, these are optical instruments. Now, we give microscope. Microscope is subdivided into two. One, we have what is called to be the simple microscope. Simple microscope. Let me hope you are able to see what I'm writing on the screen. Is it clear?
We are not seeing anything.
Okay. I can't see anything too.
Okay.
I ain't typing anything.
What about now?
Yes, teacher, you can see it now.
You can see the microscope, telescope, camera, and projector, right?
Yes.
Good. So these are optical instruments which we are going to be discussing. Microscopes. Microscopes are divided into simple microscope and then compound microscopes. So we have simple microscope and then compound microscope. These are the two types of microscope. What about telescope? Telescope, when we talk about telescope, we subdivide telescope into one, reflecting telescope. We have refracting telescopes and then reflecting what? Reflecting telescope. So these are the two types of telescopes which you have. We have those which use the principle of refraction of light. They're called to be refracting telescope. And there are those which use the principle of reflection of light, and they're called to be reflecting telescope. Now, refracting telescope, they use lenses. Reflecting telescope, they use mirrors. So here we have mirrors. These mirrors may be either concave or convex or plane mirror. A convex mirror, a concave mirror, or a plane what? Or a plane mirror. So in any telescope where we have a telescope which uses the principle of reflection, then it must be making the best use of the mirrors. Now, with refracting telescopes, those which use lenses, we have three main types. One is what we call to be astronomical telescope. Astronomical telescope is the first one, is a refracting telescope. Two, we have what we call to be the Galilean telescope. The pronunciation varies from person to person. So we say it's called to be the Galilean telescopes. Then lastly is what we call to be the terrestrial telescope. So these are the three main refracting telescopes, those which make the best use of lenses. Then reflecting telescopes, there are also three. One is called to be could. The definition, the pronunciation also varies from person to person. It's called could reflecting telescope. We have what is called to be the Newtonian reflecting telescope as well. Then lastly is what we call to be the case grain reflecting telescope. Camera, we have a simple one, and then projector, we also talk about the simple projector. Now, if you have all these instruments are the ones you're calling to be optical instruments. The other one which you have not talked about is the human eye. We can't forget that the human eye is also considered to be an instrument. Now, this is optical instruments is a subtopic itself in Physics 1, and we have seen the examples. In Physics 2, we have seen the examples of these optical instruments. According to the syllabus, the current syllabus, we are supposed to know all of them, how they work, and how to solve problems which are related to them. Now, what are these instruments then? How do we define them? When you look at the microscope, when you look at the telescope, when you look at the camera, when you look at the projector, they all do almost the same thing. And what is that? Aiding vision. They all do the same thing, aiding what? Aiding vision. Those with this smartphone, those who are not using phones, you can take the screenshot. Yes, we shall not have the time to be writing some of this. If you have a computer that you can also take the screenshot, well and fine, you can take the screenshot just for reason. Though the thing I will send them and you'll be having all of them. So all these instruments, they do one thing, they aid what? They aid vision. If you hear that somebody, before we go there, somebody talked about lens. Lens is a microscope. Lens is a microscope and it falls under simple what? Simple microscope. If we say simple microscope is a hand lens, in that for it, it magnifies the image, but the object must be placed between the optical center and the focal point. And the type of lens used in the hand lens, which is the simple microscope, is what we call to be the convex lens, which is a converging lens. So hand lens, if we are talking about optical instruments, it is good to say simple microscope, a microscope which can be divided into simple microscope and compound microscope. The one which is always in the laboratory, yes, used by the scientists, those who always see the viruses, determine the viruses, malaria virus, if it's a virus or a bacteria. The biologists will do it, will tell us better whether malaria is caused by a virus or a bacteria. But they are called to be the compound microscope. They have the eyepiece and the objective. But this one which we use to magnify the object, you want to draw, let's say, like an internal part or a small insect, but it's very small, you can't see all the features. Then you use the hand lens. Hand lens is also a microscope, but then it's a simple microscope. Please feel free, I said, feel free to submit anything. If anything you need to inquire, please feel free to raise up the hand so that at least you inquire and we move on well. I don't want you to go back the same way you came after this. When we are done, when we say that the sermon is done, you should be in position to sing the optical instrument from the beginning up to the end. Now, let's get to the definition of an optical instrument. What are these instruments which we are talking about? Optical instruments. Yes. At least you have seen the examples of optical instruments. We are saying all of them, the aid vision, the aid vision, the aid vision. What are they? How, if somebody asks you to define an optical instrument, what would you say? Yes, please. So I'm welcoming any idea from any person around. Yes, I see somebody, Prince Eno, a device that uses light for its operation. To some extent, you're correct, Innocent. A device that uses light for its operation. That was good. I'm waiting for another person, if at all is there.
An optical instrument is a device that processes light waves or photons either to enhance an image for viewing or to analyze and determine their characteristic properties.
Very good. I like the definition for sure. You've brought almost all the key points. You've brought almost all the key points which are there. I like the definition for sure. Used to view an object in order to analyze, interpret. He brought very many words there. Analyze, interpret their characteristics. Good, 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 good. Thank you so much. So briefly, when we talk about an optical instrument, yes, we already have the idea about it. But an optical instrument, like a microscope is used to magnify an object, to make it bigger. There's a question here. What about this definition? Which definition, Joseph? Can you unmute and give us the definition? And optical instruments are the devices that process photons to enhance images for viewing their characteristics. Yes, that's also true because that's what they do. Is it fine? Yes, today we are going to see a better definition of an optical instrument, though we already have them. Now, good. Let's see the better definition of an optical instrument. If we are to define an optical instrument, we say an optical instrument is a device, is the device that works on the principle. A device that works on the principle of, we have seen there are those on which are refracting. So we are saying on the principle of refraction and reflection of light rays. Devices that use work on the principle of reflection or refraction of light rays to increase the visual angle. Allow me to underline this word, visual angle. To increase the visual angle so that the object to be viewed is made to appear much bigger. And clearer with their aid. So this is what we have as the definition of an optical instrument. A device that works on the principle of reflection and refraction of light rays to do what? To increase the visual angle. So that what? So that the object to be viewed is made to appear much bigger and clearer with their what? With their LF. So this is what we have as the definition of an optical instrument. Now, I underline the word visual angle. When it comes to an optical instrument has only one main function. If I can say, what it does is only one. You hear somebody's using a microscope, somebody's using a telescope, somebody's using a hand lens. It has only one thing that it does. And what is that? It increases the visual angle. As simple as that. An optical instrument does not do another stuff, but then it increases the visual angle. Now the question is, what is a visual angle? When you talk about the visual angle, I remember I draw this diagram. I want us to see this ray. Are we able to see this?
Yes.
Good. So if I say that is my lens, and this is the principal axis of the lens. If I place an object here, this is my object O. I want the image to be formed. I pick a ray which is parallel to the principal axis. A ray parallel to the principal axis converges to the focal point. Then I pick another ray that will pass through that. So this is where our image is going to be formed. So if an object is here and this is the eye lens, remember the human eye. The human eye is a convex, it's having a convex lens. So if this is an object and this is the eye lens, then this object is enclosing a certain angle here. Are we able to see this angle? Are we able to see that angle?
Yes.
Hello?
Yes, we are able.
Good. So this angle is alpha. It is the object that is enclosing this angle at the eye. What is the eye lens? Joseph says that I'm not seeing anything. The rest, are we seeing something?
Yes.
Yes, just
The problem could be your network.
You're
seeing now.
Right now.
Okay.
Right now.
Okay, please. Fine. Thank you. So the object is enclosing a certain angle at the eye lens. So we say that the object subtends an angle. We use the word subtends. Innocent first says subtends. Innocent?
Yes, please. I'm getting.
First says subtends.
I said what?
Subtends. This word here, which I've written down here.
Subtends.
Yeah. To subtends is to and close it at a certain point. So this object subtends an angle alpha at the eye, okay? So an angle alpha in this case is going to be the visual angle. So visual angle is the angle subtended. The angle subtended at the eye by an object. Is that clear to us? The angle subtended by an object at the eye. That is what called to be the visual angle. Is that okay?
Yes.
Loud and clear.
So the angle subtended at the eye by an object is what called to be the visual is what called to be the visual angle. Now, if it's a human eye, if it is the human eye, then the human eye has the eye lens, we are aware of it. It has the eyeball. The eye lens is connected by the ciliary muscle up there. Now we are going to make an assumption that we are viewing an object which is placed in front of the eye. This is the object placed in front of the eye. So the image aren't eye lenses bad? Eye lenses are not bad. Somebody is asking, aren't eye lenses bad? That was eye lenses are not bad. They are good. Aaron was asking, are they not bad? They are not bad. They are good for sure. So if an object is placed in front of the eye, this is the human eye. That means this is our visual angle alpha. The angle subtended by an object at the eye is called to be the visual angle. The image is going to be formed here. I have a simple question. It's going to everyone. An image for a human eye, where is the image formed? Which part of the human eye is the image formed? Yes? Which part of the human eye is the image formed? Hello? Kasumba Abubeka. Kasumba Abubeka? Okay. Each part of the human eye is the image form. Sunrise, somebody has named himself Sunrise. I don't get the answer for sure. In each part of the human eye is the image form. Hello? Okay, fine. The part of the human eye where the image is formed is called...
Cornea.
Sorry?
Cornea.
I see you have the idea. Aaron?
Cornea.
Corina.
Cornea.
Okay. Where the image is formed is called to be the retina, okay? Where the image is formed is called to be the what? Called to be the retina. It's at the back of the eye here. So this part here is what we call to be the what? What we call to be the retina. So this is where the image is formed. So, very good. Sunrise said retina. Good. So now, if an object subtends this angle and the image is formed here on the retina, by properties of opposite angles, this angle is the same as that angle. So the angle subtended by the object at the eye is the same angle subtended by the image at the eye. So if the object subtend an angle of 20 degrees, then the object will also subtend an angle of 20 degrees at the eye. Remember, the distance from here to here is the length of the eyeball, which is V. So when you look at that, then tan, let's call this to be the height of the image, HI. By trigonometry, tan alpha is the same as opposite, which is HI, over adjacent, which is what? Which is V. So that means that HI is the same as V tan what? Tan alpha. So HI is the same as, for small angles, if alpha is very small, then that means that alpha, tan alpha, is approximately equals to what? Alpha. So HI is the same as alpha times V. This is the human eye. We expect the distance from the lens to the retina to be the same, does not vary. If this is a human eye, the distance from the retina to the eye, I mean the retina, from the retina to the lens, it is supposed to be the same. The eyeball does not increase. So expect the distance to be the same. So if this is the case, that means that our HI, this V is constant. HI is directly proportional to the angle, what? Angle alpha. So the greater the alpha, the bigger the size of the image. Now, it takes us to what an optical instrument can do. The purpose of the optical instrument is to increase this angle. When it increases this angle will automatically increase. And we say that if the visual angle is big, the height of the image is also what? Big. For that case, therefore, when the visual angle is big, the object appears bigger. So the purpose of using an optical instrument is to increase the visual angle, which will again which will in turn increase the size of the object. Is that clear, members?
Very clear.
Very good. Thank you, Aaron. So when we say, what is the purpose? Why do we use an optical instrument? An optical instrument is to increase the visual angle. And what is the visual angle? And the visual angle is the angle subtended by the object at the eye. Is that okay? And the bigger the angle, the bigger the object. The smaller the angle, the smaller the object. Is that clear? Good. So let's go on, unless somebody's having any question to ask, feel free to ask any question. Feel free. I told you by the time we leave optical instrument, or by the time we leave here, we shall go when we have very many ideas about optical instrument, and it will not be a problem for us. So briefly, this is what I wanted us to know at the introduction part before we get to the question. Let's get to the question. First question in our start. Our first question, hope you are able to see my screen again. Are you able to see on my screen? Are you able to see on my screen? Are you able to see on my screen? Let me know. We are going to the first question. Define the term visual angle as applied to optical instruments. Is that the first question? The first question says, define the term visual angle as applied to optical instruments. I guess we have already defined this for sure. We have already defined the visual angle. We said the visual angle is the angle which is subtended at the eye by an object. So we said this was our visual angle. The visual angle is this angle, alpha. I'm going to test, I don't know whether, who is using a computer? You could read for us the second question. Is there anyone using a computer? Joseph, Gonzaga, and Jean, is there anyone using a computer? Or somebody who can read for us the question, the second question? Hello, Aaron, can you read for us the second question? Is it possible? It's fine. Okay. Seems there's someone who can read the question. It's okay. Fine. Let's go to the next question. The next question says that explain why the farthest vertical pole in line with others of equal height looks shorter.
Could you please repeat?
Did you write the question? Explain why. It is explain why the farthest pole. I sent the question in the group. I thought that you saw it. Did you see the question? Are you able to see on the screen? Hello?
Yes, I am able.
Yeah,
Yes,
the rest are not talking. Please, I said we have to talk and we participate in this, okay? That is how we will benefit. Good. So we are answering part B. Explain why the farthest vertical pole in line with others. Why the farthest vertical pole in line with others will always appear what? Shorter. That's what we are explaining now. Why the farthest vertical pole in line with the others will always be what? Will always be shorter. We are answering that right away. Let me share the screen and then we move on. So this is a question we are answering. Why the farthest vertical pole in line with others of equal height looks shorter? Is that true anyway? Before we start the explanation, is it true that they appear shorter? If you have the pole, the electricity pole, 10 of them in a straight line, the last one, the other side, appears to be the shortest, and yet they are of the same height. Have you ever experienced that?
Yes,
Gonzaga,
teacher.
have you ever experienced that, Joseph?
Yes, teacher.
One thing which I love about physics is that it is used to explain physics. There's nothing that physics cannot explain. So I like physics because of that. Actually, I pity those who are doing A level and they are not doing physics much well. They are missing a lot. They cannot explain very many things. They just see things happen and they cannot tell why they are happening that way. But with physics, when you see a rainbow, physics is able to explain how rainbow is formed. Though it was a covenant between God and Noah, but even physics can go ahead to explain to you how it is formed. And you can be well convinced that really it's true. Now, let us answer this question. Now, the question is asking us, why is it that the last
Yes, teacher, I'm not getting you.
The last question which they were saying is that we explain why the last pole will always be short. The last pole is going to be shorter always, but we have to appreciate that the size of the object depends basically on the visual angle. Do you hear that?
Yes, I'm getting it.
We said if the visual angle is small, what will be the size of the image? Is it small or big?
It's going to be small.
Very good. Now, let us consider 3 poles, okay? We are going to consider 3 poles placed in front of the eye. Are you able to see this? This is the first pole. This is the second pole. And this is the third pole. Are we seeing those 3 poles?
Yes.
Good. Now let us start with the first pole. We start with the first pole. Do you see the angle subtended by the first pole?
Not very clearly.
That angle, that's the angle subtended by the first pole at the eye, okay?
We are not seeing.
Oh, let me share the screen again. Are you able to see now?
Very clearly.
Yes,
Good.
I can see it.
Are we seeing the angle subtended now by the first pole? It's this angle, right?
Yes.
Let us call it to be alpha, okay?
Yes.
This is the first pole, this is the second pole, this is the third pole. Let's go to the second pole. We are going to draw a line up to the eye. I see that. Do you see that angle? I see this angle subtended by the second pole.
Yes, teacher.
Let us call it to be beta. Then lastly is the third pole. Up to there. Let us call it to be X. We are able to see 3 angles, right? There's angle alpha, there's angle beta, and there's angle x. All these are visual what? Visual angle. Alpha is the visual angle of the first pole. Beta is the visual angle of the second pole. And x is the visual angle of the third pole. My simple question is, which angle is the greatest there? Which angle is the greatest, is the biggest? Which of the three angles the greatest?
For the first pole.
Pardon?
For the first pole.
The first pole.
First pole.
So that means alpha is the greatest, not so?
Yes, teacher.
Followed by which angle? Beta and x. Which one is bigger than the other?
Beta.
Beta, and lastly what? Lastly x, right? Remember, we said that the angle, the size of the image depends on the visual angle. Is that true? The size of the image form depends on the visual angle. And so, the greater the visual angle, the bigger the image, and the smaller the visual angle, the smaller the image. Now the question is, pole 1, pole 2, and pole 3, which one will be bigger than the other?
Pole 1. Pole 1.
Which one is going to be the shortest?
Pole 3.
Does it answer the question now?
Yes, teacher, you can answer the question.
Does it answer the question?
Yes, teacher, you can
Very
answer.
good. So, good. Let me hope it's very clear to everyone, okay?
Yes.
So we shouldn't be surprised once again anymore to see that the farthest pole is very short. And when you get closer to it, it is what? It is becoming taller. For us physicists, we don't get surprised. That one is for the historians. They don't know why. Those who are not doing physics, the biologists, the chemists, they don't know it. But for us physicists, we say, the other farthest pole, for sure, the angle is subtending in my eye, at my eye, is very small. So the smaller the angle is subtended at the eye, the smaller the pole. So it appears to be short. Is that clear?
Very clear.
Very good, very good. So that is that when it comes to the visual angle and its effect. So the next day you find the same question anywhere, just chop. In physics, I don't say that you write. I normally tell people to chop. Just chop the number because it's always very simple. Now let's go to angular magnification. Are you able to see on my screen?
Yes, teacher.
We are going to part B. What does it say? Part A, define the term angular magnification of an optical instrument. Is that okay? Define angular magnification of an optical instrument. So when you're talking about angular magnification, it's different from linear magnification.
Rahma.
Innocent, can you read for us the definition of angular magnification? Innocent? Are you there, Innocent? Okay, Aaron, can you read for us the definition of angular magnification? Yes, Aaron? Okay, let us hear from Kasumba. Abubakar. Abubakar? Abubakar? What's an angular magnification? I've written it on the board. Namakula Ruth. Hello, Ruth. Hello, Ruth, unmute. Oh. Jonathan? Jonathan, can you unmute? Hello, Jonah? Okay. Everyone is not unmuting. So we are talking about angular magnification. Now, when talking about angular magnification, as far as an optical instrument is concerned, it is something very important. Angular magnification is sometimes referred to as magnifying power. If we are talking about angular magnification, it's sometimes referred to as magnifying power. Magnifying power is the ratio of the angle subtended by the final image at the eye when you're using the instrument to the angle subtended by the object in an aided eye. Actually, this one should be at unaided eye. That is when the instrument is not in use. So we said that when you have an optical instrument, the use of the optical instrument is to change the visual angle. So if you use the optical instrument, without the optical instrument, the visual angle is always alpha. That is, if you are just seeing the pole without the optical instrument, the visual angle is always alpha. But now, a moment you change the optical instrument, then the visual angle, a moment you bring the optical instrument, you start using a microscope, then the visual angle changes automatically. So the visual angle now becomes alpha what? Alpha prime. This is without an instrument. Then this is with what? With an instrument. So we're saying that without an instrument, the visual angle is alpha. With an instrument, the visual angle is alpha prime. Now, we say magnifying power is capital M. Is the ratio of the angles obtained by the final image at the eye with the instrument in place. That is alpha prime. To the angles obtained by the object without the instrument. That is alpha. This is the expression for magnifying power. I don't know whether I'm clear. Am I clear? Am I clear? Hello, Carl Cass, Joseph Gonzaga, Aaron, Abubakar.
Yeah, I'm online. I'm hearing.
Is it clear? It's not just a matter of being online. We have to be sure that things are clear, okay?
Yes, teacher, I'm getting you.
Okay, please, fine, thank you. So that is that when it comes to magnifying what? Magnifying power. So magnifying power is the ratio of the angles obtained by the final image at the eye when the instrument is in use to the angles obtained by the object at an aided eye. That is without the instrument. Good. Let's go on to the next question. The next question is saying, give the reason why the focal length of the objective of the telescope is always much longer than that of the eyepiece. Why the focal length of the objective of a telescope is always much longer than that of the eyepiece. So this is just to increase or to obtain the larger magnifying power. Or to obtain larger angular magnification. That is why it should always be what? To be longer. So when we are going to discuss, or when you look at the telescope, which is astronomical, you find that the objective is always greater than what? Greater than the eyepiece. So as to obtain the greater magnifying power. When the magnifying power is big, then that means that you'd be in position to see the image clearly. So that's the good thing with it. What is meant by normal adjustments as applied to telescope? In telescope, we start talking about some terms which are very good, interesting, but new to us. That is normal adjustment. Then we have not normal adjustment. Normal adjustment, not normal adjustment. Now, when we talk about normal adjustment, telescope, Maybe I may ask, telescopes are used to view distant objects. Telescopes are used to view distant objects. So it must bring a distant object to the near point. Now, when you talk about a telescope, normal and not normal, a telescope is said to be in normal adjustment if one, first of all, it's used to view distant objects. One, if it picks the object, a distant object here, we also call it to be infinity. Object at what? Object at infinity. Object at infinity is the object which is very far. So a telescope is said to be in normal adjustment if it picks the object from infinity and forms the image at infinity. Object from infinity image at infinity. Object at infinity, image at infinity. That way, you will have your telescope, and that type of telescope, we say that it is forming the image at infinity, and it is in normal adjustment. What about not normal adjustment? When it's in not normal adjustment, it picks the object from infinity and forms the image at a near point. Object is picked from infinity and is formed at a near point. A near point is the distance, is the shortest distance from the eye that the object,
Not seeing.
that when the object is placed there, it can be seen clearly. Sometimes it's called to be least distance of distinct vision. Least distance of distinct vision. So an object, if an object is at a near point, then it is at a least distance of distinct vision. For a normal eye, least distance of distinct vision, where when you place your object, you will see clearly. Okay, Claude says that he's not seeing anything. Let me reshare the screen. Let me know whether you're seeing again. Are you seeing? Cloud?
Yes, I'm seeing it.
Good. So we are saying that for a telescope to be said that is in not normal adjustment, then the final image should be formed at a near point. And we said that a near point is the distance from the eye that when an object is placed there, the image is seen, the object is seen clearly. And the distance from the object, the distance from the near point to the eye is called to be least distance of distinct vision, and it is always about 25 centimeters. Least distance of distinct vision is always about 25 centimeters away from the eye. So when an object is at about 25 centimeters from the eye, you will be positioned to see that object clearly. So when a telescope forms an image, when a telescope forms an image at a near point, then that telescope is said to be not in normal adjustment. When it forms an image at infinity, the telescope is said to be in normal adjustment. Have we gotten the difference between normal adjustment and not normal adjustment?
Yes, I've got it.
Okay, please. Fine, thank you. Let's move on. The other one I was saying, draw a ray diagram to show the action of astronomical telescope in normal adjustment and derive the expression for its magnifying power in terms of the focal length, f0, and the eyepiece, fe, of the objective and the eyepiece, respectively. I normally like these questions of optical instruments because they're always very simple. I normally tell my students that physics is porridge. When you find physics a problem, be sure that you have not yet understood physics. Physics is porridge. I think you, some of you take porridge at school, you find that you can even take porridge without escort. That is how physics is. You can even understand physics without the teacher. Very simple thing to understand, especially this physics of A level of ours. Very simple. You can sing from the first page to the last page without any struggle. Let's see. They're saying astronomical telescope, not in normal, in normal adjustment. And I've just said that if a telescope is in normal adjustment, then the final image should be formed at infinity. A telescope has two lenses. Let us start the ray diagram. Hope you are seeing on my screen. Are you seeing on my screen?
No.
No, I'm not seeing anything.
What about now?
I'm not seeing the screen.
I'm
You're
just
still
seeing
not
your
seeing?
cursor. I'm just seeing your cursor.
But I see on my board.
Yes, Jamaica can see your cursor.
Sheldon, can you hear us?
Yes.
Hello, Sheldon, yeah? Sheldon, are you there?
Hello?
Yes, are you there?
Yes, please.
Go ahead.
My cursor tapped on the, hello?
Yes, now we can hear you.
Good. So we are talking about an optical instrument, astronomical telescope in normal adjustment. So this is always the eyepiece. Eyepiece. Let me hope you can see on my screen.
Yes, teacher, I can see.
Let me adjust the eyepiece so that let me give this one to be the objective so that I put the eyepiece here. So this is my eyepiece. Eyepiece. And this is my what? My objective. So we draw the principal axis. This is our principal axis. Now, we are saying that the final image should be formed at infinity, okay? Remember, the object is at infinity. So you want the final image to be formed at infinity as well. So if the object is at infinity, we pick two rays. The first ray is here through the optical center. The first ray is through the optical center. Are we able to see this ray?
Yes.
So this is our first ray. The ray through the optical center will pass through undeviated. Then I measure this one. This is the focal point. This is also a focal point. So we pick another ray, which should be parallel. It should be parallel to the first ray which I've picked. Should be parallel to this ray which I've picked. But must pass through the focal point. I see these two rays. This is F naught. So this ray is going to be refracted parallel to the principal axis. Have we seen the ray diagram for that? Hello?
Yes, we are seeing.
Good. Now, this was the object from infinity, okay? So the object from infinity will be formed at the focal point F naught. The object at infinity, when it falls, when the ray of light from object at infinity falls on the lens, the final image is formed at the focal point of the objective. Then, the focal point of the objective is always placed, is always in such a way that it is also at the focal point of the eyepiece. Do you hear that? The focal point of the objective is always at the same point as that of the eyepiece. Is that okay?
Yes, teacher.
Good. So that means this image is at the focal point of the eyepiece again. So it is a focal point. Make sure you make some measurement. It is a focal point from here to here. Should be the same as from here to here. So we pick another ray through the we pick that ray. This is a ray through the what? This is a ray through the optical center. Then this ray is parallel to the principal axis. So it will converge to the focal point. So when it converges to the focal point, you see these two rays are parallel. So they appear to be, it appears to be coming from this side. Let me try to wrap that. So this ray appears to be coming from here. So this is how the final image is formed on the what? On an astronomical telescope. The final image is formed this side at infinity. This is the final image at infinity. So that's how it is formed. And that is how we draw the ray diagram. It's very simple. Now, the most important thing is to know that object from infinity is formed at the focal point of the objective. The focal point of the objective is at the focal point of the eyepiece. So that means this object is also formed at the focal point of the eyepiece. When the object is at the eyepiece, then the final image is taken away up to the what? Up to infinity. So this is how it is formed. Any question is welcome. If you have any question on that, or any supplement is also welcome. Good. If there is no question, then let us go on and we wind up on this. Now, we are talking about the magnifying power. If we are to derive the magnifying power, we said magnifying power, M, is the same as alpha prime over what? Over alpha. Where alpha prime is the angle subtended at the eye by the final image when the optical instrument is in use, and alpha is the angle subtended at the eye when the optical instrument is not in use. So alpha is provided by the object. So this distance, you look at this distance from here to here is F naught, and from here to here is FE, sorry. The distance from the object, from the objective lens to this image is F naught. The distance from this one, this object, to this lens is F what? FE. The object is somewhere here very far. The object is very far, but if I was to draw this object, this would be the position of the object. So it is subtend this angle here. So this is alpha. The angle subtended by the object, which we assume to be very far, which is the same as this angle alpha. Is that clear? Hello?
Yes, yes.
Is it clear?
Yeah.
Good. So,
Yes.
I'll use tan alpha. Tan alpha equals to opposite. What will be the opposite? It is H, not so? Is it H over what? It's going to be H over what? Isn't it H over F naught? Hello? Tan alpha is going to be H opposite over adjacent, which is F naught, not so? Good. Then for small angles, we say that for small angles, tan alpha is approximated equals to what? Alpha. So that means that alpha is going to be h over f naught. Then we go to alpha prime. Alpha prime is the angle subtended by the final image. Remember, the final image is at infinity, this side. The final image is this side. So if I'm to assume it is also like that, this is the final image which subtends the final image is this side, which subtends this angle. So that is tan alpha prime. So you say tan alpha prime is the same as opposite, which is still what? H. It is opposite divided by adjacent, which is FE. So that means that alpha prime is the same as H over F what? FE. So our magnifying power is alpha prime over alpha, which is going to be alpha prime. It is H out of FE. H out of FE, then divided by alpha, which is H out of F naught. So eventually we shall have H out of FE times F naught out of what? Out of H. So that H can go. We remain with the M to be equals to F naught out of what? Out of FE. This is the expression for the magnifying power of an astronomical telescope in normal adjustment. Is the ratio of the focal length of the objective to that of the eyepiece. Is that clear, members? Is it clear, members?
It is clear, sir.
Fine, thank you. We are supposed to use 1 hour and 30 minutes. Unfortunately or fortunately, we have already used more than that. And we are very sorry for that, but we are saying that we still had more questions to do. What I'll do, I'll share the questions with everyone. At least I've shared already in the group. Check through the question. In case there's something which you want us to discuss together, come and we talk about it in Yaka. For now, I would wish that we stop over here, because if we say that we're going to discuss all the questions, it may take us even 5 to 6 hours. So those questions, you're going to discuss them in your respective schools or with your friends or with a colleague. But in case something is not clear, I challenge you to come back to us and talk to us. The physics teacher is teacher Daniel Alera. I'm writing the contact here. Are you able to see this? Are you able to see this?
Yes, sir.
070 375 0387 or 0789 94 44 24. Is that okay? There's also a contact already. There's a contact already in the chat. So that one is for our office.
Yes, sir.
So you can contact our office on 0770 730 170. So you will contact us in case you have more questions, in case you want to understand more stuff. Please, in Yaka, we do things the way you have seen them here. You can study in Yaka for over 2 years. You sit for your exams, you pass without any problem. We have qualified staff. We can guide you on how best you can do it. So feel free to contact us at any time at your convenient time. And I take this chance to welcome one of our administrators to say a word or two before he or she closes this. Thank you so much.
Oh, thank you, Teacher Daniel, for this wonderful session. My name is Pascal, and I'm admin at Yaka Digital Network. I've so far put the contacts in the chat for our offices, and in case you need any help regarding physics, chemistry, mathematics, any combination, any subject you're taking, please feel free to reach out. Our teachers, like you've seen, Teacher Daniel, will be available at any time to help you out. Yeah, so I would wish to stop from here. Thank you for participating. Thank you for attending. And we're having more of these seminars. Even next Saturday, we shall be having one. So the contacts are there. Please stay in touch so we can always get informed about such seminars as when they happen. So in case you have any questions regarding the using
Thank you
of
very much. We wish also to have a session of mathematics A level.
Oh yeah, that one is coming up, and I'm going to send you a link for if you've not yet joined in the seminar group we have. Let me send you the link right away, so you can join. So I'm going to send you the link for the group. Hope you can see it. Can you see it in the chat? So this is the group we created for the seminars. So in case there are more seminars coming up, that's why we communicate to them. Please join in, and the mathematical seminar will be upcoming. So any other questions? Oh, so if you don't have any questions, allow me to wish you a good evening and a good weekend. Thank you.
Thank you everyone for participating. Goodbye for now. See you then. Feel free to contact us at any time, anywhere. We are ever online, ready to serve you. Please tell a friend who has not heard of this. Tell a friend to tell a friend. We can pass physics together here, especially the A-level physics. Mathematics, the same way. Chemistry, the same way. Please tell a friend so that you don't enjoy this alone. Goodbye for now. Have a nice evening.
Nice evening too. Thank you.
Yeah.